Hello and welcome to another video for Python for Artificial Intelligence. And in this video, we will learn about recursions in Python. So recursion is a programming technique and where a function calls itself in order to solve a smaller instance of same problem. So this approach helps in breaking down complex problems into simpler, means more manageable parts. So how recursion works, and the thing is that every recursion function must have two main parts. The first is base case, the condition that stops a recursion from continuing and indefinitely. And the second is a recursive case, the part where the function calls itself with modified argument to work toward the base case. Means it will progress towards a condition where the base case is satisfied, so it can stop calling itself. Like this is the function, and in the else case, you can say the recursive case. You can see that you are calling itself, so it should progress towards a condition where the base case, the if condition here, is become true, so it can break itself. So to explain this, we can say that in this basic structure of recursion function, we have a function name. We have a function name, we have a base condition, and we have a parameter, and condition, the base case that stops the recursion, and the value returned when the base case is met. Okay, and new parameter here, the updated parameter passed to the recursive call when calling the function, when the function call itself again. I think it would be more easy if we could demonstrate it with a example. So let's to demonstrate, we can take our example of a factorial. If you know factorial, what is factorial? So it's a recursive multiplication of numbers of series. So let's find out. So for example, if we need factorial of 4, here you can see that the factorial of, we need factorial of 4. What it does, it multiplies 4 by 3 by subtracting 1 from 4, and then result of this 4 by 3 is multiplied by 2 minus 3, 3 minus 1, and so on, and we get the result 24. It is represented using a factorial sign. So how we do it with the help of recursion in Python. So what we can define a function factorial, and and we have a, you can take an argument, and here we can say that we have a base case where we have a condition if n equals to 0 or n equals to 1. In that case, it will return what? 1. Okay, and in the else case, this would be recursive. Recursive case, here the same function will be called from this code. It will call itself So here we can say that we have a else situation where we return what, and a multiplication, multiply the n with the, here we also call the factorial function with n minus 1, subtracting 1 from the original input given while calling the function from outside this function. So I hope this is it, and after that what we can say, we can print, we can call the function, and here we say like factorial is, and we call the function, provide the, let's say if we want to find out the factorial of 5, so here we go. So it's working perfectly fine. So what is happening here is that we have defined a function that will take a single argument, the value for which we have to find the factorial. So base case is if n equals to 0 or n equals to 1. In that condition, this recursion will be will exit. Otherwise, it will keep repeating itself. So we have provided the 5 number here. So first, when it tested here, this condition will be false, so it will not run this code. And the else condition, this recursive case, is that we are calculating and by multiplying the n variable, the 5 here, and with the 1 minus, subtracting 1 from the provided integer value, and we here also calling the same function itself, and again here the value will be 5 minus 1, that will be 4. So it will again check, and this will not be the case, and it will go again here. Now the previous result is not completed here, because before completing the previous result, it has called itself again, and that 5 into 4 n minus 1 is already there, held in the memory of the system of this function, the first call that we made through this statement. So if what it will do, it will keep keep looping, and not looping is not the exact word, but it will recurse here again until this value is not proven true. So what is going on here is that the key is to trace the order in which the function calls happens and the values are returned. So this when this becomes true, now the remaining the functions that were in pending start to add up one by one. So that's why we got the here value 120. I hope you got this. And for example, so if we change it to like 4, okay, so here you can provide any number here and you will find the factorial of that particular number. So what if I provide a -10? What will happen here? It will overflow. It will not provide any information, and because here the both values are in negative, when we call here, it will be minus 10, and it will be adding instead of subtracting toward the negative value of the integer. So there is a limit how much recursion um, the system can do, and after the maximum recursion depth is exceed. So there is a limit by default in place to avoid any overflow, or any to avoid any situation when you make the system halt by not meeting a situation or a condition where the base condition becomes true. So how do you find what is the recursion limit for the system? So for that, what you can do is that you can find it out by you have to import a library, and after that this function, like let's say here dot get recursion limit. So what it will do, it will show you the recursion limit. So it is currently set to 5,000. After 5,000 of recursion, it will overflow and provide you an error. You can also set this recursion limit by function here that is like set thing. Yeah, it is. Or you can increase it to or decrease it. For example, I want to set it to 2000, and okay, it's saying none. So let's try to print. Okay, so now it's set. Previously it was set to 5,000. I have reduced it to 2,000. You can set it to any number you want based on your requirement, but be careful that it will affect. You have to understand your capacity of your machine that can handle that number of recursions. So there are pros and cons of recursions, and it simplifies the complex problem and makes code easier to understand, and it's useful for tasks with nested structure. So downside is it can lead to performance issues, and it's always a risk of hitting recursion depth unless you understand what will be the maximum and the minimum possible recursion you have. Sometimes it's less efficient than the iteration. So I hope you have understand the recursion in the Python. So hit like if you find it useful, and if you have any question, post in the comment section, and thank you for watching.